So now we are going to write equations to solve problems, and many real-world situations can be modeled using linear equations. Here's an example. We have Donna offering computer services to small companies in her city, and she charges $50 per month. That means $50 times the number of months, right? So let's do a times on the per. For maintaining a website, and $45 per hour for each service of call. So again, with the per, it's times, right? So write an equation to represent the total monthly cost, capital C, for maintaining a website and for H hours of service. Okay, so since we have here a monthly cost, that sounds good. So that means that she's going to charge $55 for that 1 month. And then during that month, for every hour of service call, we need $45 per hour. She's going to charge $45 per hour. Okay. So for each hour, the cost increases $45. Yes. And the rate of change or slope is 45. The y-intercept is where there are 0 hours. So again, if you buy Donna services, but you have 0 hours of service calls, she's still going to charge you $55 a month. Right? So this might be easier to see if we graphed it. So this is the hours, would be the x-axis, and then the y-axis would be the cost. So if we have 1, 2, 3, 4, 5, we have 1, 2, 3, 4, and 5. At 1 hour, the cost is going to be $45, right? $45 per hour. But actually, she charges $55 as a base fee, right? A base fee. So then it's going to be 55 is here, let's say. And then if there's 0 hours, like there are at the origin, then she's going to charge $55. But if there's 1 hour of service call, then she's going to charge $55 plus $45 for that 1 hour of service call. So it's going to go up to $100. And then if the person has 2 hours of service calls, then that means it's going to be 55 plus 45 times 2, right? So 45 times 2 is 90, so 55 plus 90, so it's going to be 145, like so. So you can see here we have this linear graph, right, that can predict, depending on how many hours of service call a client orders, how much their cost would be. And so the way that we can model it using slope-intercept form is cost, that's our y-axis, is equal to the slope, which is going to be our $45 per hour, right? So this is our slope m, times the number of hours, and we don't know how many hours that they are asking for, so we are using H for hours, the unknown number of hours, and then plus the base fee. And so she charges $55 per month. So this is the base fee per month, right? This is the cost per month for 1 month. So you could see that we have total cost is equal to 45 times H plus the base fee of $55. And we get a graph that looks something like that. Now, Donna may change her costs by representing them by the equation C is equal to 25H plus 125. So $125 is the fixed monthly fee for a website, and the cost per hour of service is now lowered to $25. Right, so she increased the fixed cost from $55 to $125, but she decreased her monthly rate of coming out and working on the website to $25. So compare her new plan with the old one if the company has 5.5 hours of service call. So how would we do this? Well, the first plan, H is equal to 5.5. And in the first plan, we have this equation, right? C is equal to 45H plus 55. And we're plugging in 5.5 for H. And we calculate what's the total cost, and it's going to be $302.50. The second plan, we have the same number of hours. H is equal to 5.5 because we're comparing the two plans under the same number of hours. And so the equation for the second plan is cost is equal to 25H plus 125. And we're plugging in 5.5 for H, and we get $262 under the second plan. So Donna would earn more with the first plan, right? So this would be a more lucrative service to offer. And then the second one here would be more of a deal if the person has a lot of service hours. So now we have our exercise here that you're supposed to do on your own. And this is Jerry and his satellite service. You can see he has a flat rate of $34.95. This is going to be our B, right, or our y-intercept. And then he charges an additional $10 per month for each premium channel. This is going to be our M, right, our slope. And then we have a second competing service that charges a flat rate of $39.99. That's going to be our B, the flat rate. And then the cost per month for each premium channel is going to be our M2, right? So this is our M1, I guess, and our B1 and our B2. So B1, M1, B2, M2. And then what are we supposed to do? Well, we're supposed to write our two equations, right? We're plugging in. And then we're checking, okay, if P is equal to 3, right? They want 3 premium channels. If P is equal to 3, then which one is going to cost less? And so we plug in, and we figure out what it costs. And the competing service is going to be cheaper in this case. And then down here, we have this third company that doesn't have a per channel cost. All it has is a flat rate of 69. And what kind of equation would that come up with for total cost? It would be total cost, the Y, is equal to 69. That's it. Right? So now we're comparing if we want to add a fourth premium channel. So that means P is going to equal to 4. And we plug into equation 1 and equation 2. And we say which one is the cheapest. And it comes out that the third satellite company is the cheapest company. Right? And then we're over here. How is the fee for the number of premium channels reflected in the equation? I think I got this one wrong, actually. The fee for the number of premium channels would be our slope, right? The base fee is the y-intercept. So let me go ahead and rewrite this. The base fee is the y-intercept. The fee for each premium channel is the slope, like that.